Lesson 5, the discovery of the atom. This is not a single discovery, but rather a series of theories, experiments, and advancements in science and technology which will lead to our modern picture or idea of the atom. We go back to ancient times and the Greek word atomos from the Greek philosopher Democritus, and he proposed that the matter, which is stuff, the elements all around us, is made up of atoms. And what he meant by an atom was that the smallest piece of something that can exist. So if we take an object, chop it in two, we've got two parts, take one half, chop that in two again, we've got 4/4, and so on and so on. And he theorized that you will get to a point where you cannot cut it into two any further, and that is the smallest piece of matter, which he called the atom, well, which is called the atom from the Greek word atomos, which means indivisible, cannot be split further. So that's where we were up to around about 1800, and John Dalton proposed the idea that these atoms were different for different elements, and that the atom was a solid ball of material. Okay, so one solid ball of material, a bit like a snooker ball. Then in 1898, J.J. Thomson, in some experiments, discovered the electron, and he proposed that this was the electron, which was part of the atom, and the atom was actually made up of, rather than a solid ball, it was made up of a positive charge and negative charges in one ball, which he called the plum pudding model. Then developments become to accelerate quite a lot. Ernest Rutherford, with his students Marston and Geiger, done experiments which led to the nuclear model of the atom, and he was trying to prove J.J. Thomson's solid ball with positive and negative charge was correct. Well, he actually proved what that model was not correct. The results of that experiment said that the atom was actually mostly empty space with a positive nucleus in the center, which contains all of the mass, and around the outside was the electrons orbiting. Niels Bohr in 1922 improved this model by saying that the electrons orbit in several levels called shells. So you could have different levels. And then further improvements came with James Chadwick's discovery of the neutron in about 1932, and he said that in the nucleus then was protons and neutrons, which leads us to the timeline model, that the early model of the atom was our solid sphere. Then J.J. Thomson's discovery of the electron led to a new model which had the atom as a solid sphere containing positive and negative charges. Then Ernest Rutherford's discoveries led to the nuclear model, which said that the protons were in the center of the atom in the area called the nucleus, and outside, a long way away, were electrons, which meant that the atom was mostly empty space. And then our latest model of the atom, which has that the nucleus contains protons and neutrons, which contain pretty much all the mass, and some distance outside, orbiting around, are different rings or levels or shells of electrons which spin around, which we can see that summarized in Appendix A8, John Dalton's model, positive and negative charges. Rutherford's model was the nucleus, and outside you have orbiting the electrons, and our modern atomic model, which has the protons and neutrons in the center, and outside orbiting at various different shells, only one shown here, are the electrons. So the proton has a positive charge of +1, the neutron has no charge, and the electron has a negative charge of -1, and this is the relative size. In the scale of the proton, say, was the size of a football, an electron would be the size of a grain of sand. And that is our current model of the atom.